Hello, guys. Thank you for coming. My name is Joey. I will be your presenter today. And yeah, today's topic is practical testing in Databricks. I'm a software engineer. I'm not a data engineer by profession. I've only recently dove into that field. And the aim of this whole workshop is how can we bring sort of testing practices that I've used as a software engineer to the data engineering world. So, quick show of hands before we begin. How many of you have used Databricks before? Okay. So that's four people. Okay. I mean, it doesn't matter. Just any sort of connection with it. Cool. Well, just to explain to the rest of you guys, Databricks is a data engineering sort of cloud platform that it's a data warehouse that allows you to build data pipelines. They have a very nice sort of AI product offering on top of that, where you can train your machine learning models, you can train models on your data, you can chat with your data, so all that good AI stuff that we keep hearing about everywhere. Everybody likes to do AI these days. But yeah, so the main sort of way Databricks works is have any of you used Jupyter notebooks with Python before? A lot more people, yeah. So it's basically sort of a notebook-based format. You have a bunch of cells where you define code. You can also have Markdown. You mix it with descriptions. You can have different languages in Databricks. You can have Python and SQL. You can have Scala, R. So I'll show you guys basically what the interface looks like. But let's move on to the next slide. First of all, a little more about me. So that's a nice photo captured in France years ago where I'm posing, thinking I look cool. But anyway, my career started originally in acoustical engineering. I have a background in acoustics and specifically signal processing. So I started working with an audio startup back in the 2019. And we were working a lot with Python and C++, building out a soundbar that was creating some 3D audio, essentially. And but even at that time, I had a lot of interest in web technologies, full stack. I was learning PHP, HTML, JavaScript, jQuery, all the good old libraries from back in the day. So yeah, I moved to full stack engineering by joining Sahaj. It's been about 3 years now. And it's my first time being a consultant as well. So during this time, I've been on 3 projects. I'm on the 3rd project in different sort of industries. And yeah, as part of my work, I've slowly kind of gravitated towards data engineering. It's been a lot of data engineering work. I'm on a project that is purely data engineering based today, and it is on the Databricks platform. So here we are. Right. So what you're going to learn today, we're going to discuss about the importance of testing your data pipelines. We're going to talk about the different types of testing, which I presume a lot of you are probably already familiar with. And we're going to talk about, so essentially, just to take a sort of step back, Databricks offers a variety of languages you can work with. You can work with SQL, you can work with Python and Spark. Scala and R. We're going to be focusing purely on Python in this example, but you can definitely sort of take this approach and use it with different languages as well. I haven't explored that territory yet, but in theory it should be feasible. So we're going to talk about how do we structure testable PySpark code using sort of best practices, and how do we make this code that in a format that is suitable for testing. So one of the things that I've noticed, and what many of you have noticed probably working with notebooks, is they're kind of a very nice sort of environment where you want to experiment and explore and do things and change things and run different sort of cells in different orders, and that's all great. But I think personally, myself, and it's a really opinionated perspective, a lot of people will probably disagree with me. They love their notebooks. But I think that can sort of lead you towards some bad habits that then make your data pipelines harder to test. So we're going to be focusing specifically on how can we set up tests that can actually run locally away from Databricks and in your CI as well. So obviously Databricks, you can run a full data pipeline test by deploying your pipeline. providing some sample data and running it through. But obviously that comes with its own associated costs. It ties you to the platform. It takes longer to run tests. So how can we sort of take a bit of that weight away and just bring it down to a local environment? I'm very pro doing things locally as a developer. So yeah, and then we'll talk about how do we integrate these tests into our CI/CD workflows, specifically GitHub Actions. And we will be using PySpark and Azure. So Databricks is available on all these sort of big cloud platforms. We'll be focusing on Azure because that's the only kind of experience that I have interacting with it, and not on AWS and GCP. But it's pretty much the same thing. Right. So let's talk about the importance of testing data pipelines. So obviously they're very important. Data pipelines, they handle large, complex, and constantly changing data that creates unique risks. So what happens? You have your data pipeline, you get your source data, you build out your layers, transformations, and then you have your presentation layer, which your consumers use, you base your reports on, right? This is very important, right? Small errors in raw data will cascade into your reports, and they can lead to inaccurate analytics, poor decision making, and they can erode the trust in your company. They can also cause pipeline failures, which give you downtime, delayed reports, and there's maintenance challenges associated with that. So testing ensures that they are reliable and correct. And just like software engineers, I think we should validate every sort of transformation every step of the way in a data pipeline. All right, so the problem. Unlike frameworks like dbt and SQL Mesh, has anyone used dbt or SQL Mesh before? So you guys are familiar, they have a very nice sort of testing workflow, right? You got your schema tests straight in your models, you got your unit tests you define as SQL code. It is all there is an opinionated workflow with that. Unfortunately, Databricks does not have an opinionated testing workflow. Their approach basically on their website is, well, if you're using Python, just use the Python testing libraries, which is unit test or PyTest. And that's great. But I think when you have sort of a notebook kind of like environment and you tell us to just use these libraries to test, it kind of becomes a bit of a free-for-all, right? So, well, how do we test it? What's the best way to structure our code, right? So they're saying, use common Python tooling. They also say that they recommend running your unit tests in a notebook. And by running unit tests in a notebook, they're actually meaning you have your code block, you import PyTest, and you run PyTest against your tests, which to me feels a bit redundant because you can just run PyTest in the command line. You can run PyTest anywhere. It doesn't have to be in a notebook. Right, so what practices can we adopt with these tools and incorporate good testing for our data pipelines? So we're going to talk about the types of tests, which you're all probably familiar with. So we got the unit tests, where we're testing our individual functions in isolation. It is single responsibility, usually very fast to test these, and I think basically we should use that anytime we have a function. I think anytime we have a transformation, anytime a type of logic, I think we should write unit tests for it. So there we go. We have a quick sample code for validating a data frame. We've got our orders, and basically we have to test that individually. Now moving on, we have integration tests. And some people call them component tests. Some people use them interchangeably. I will not differentiate between the two at this point, but basically this works. This is how multiple parts of your pipeline, your software architecture, how do they work together? We're testing that, right? Multiple functions, data flows. The speed is a lot slower, but we should probably use this whenever we're doing any end-to-end transformations. So for example, in a data pipeline, you have your layers, right? You have your bronze layer, if we're talking about a medallion architecture. So for those of you who are not unaware, your bronze layer is typically where you ingest all your data, raw without touching it, and then you promote it to your silver layer, where you begin to perform your transformations, your cleanup, your validation. You can also do some cleanup and validation in bronze. It's just naming things at the end of the day, right? And then your gold layer is pretty much your presentation layer, where all your sort of consumers come and they take your data, or it goes into some BI analytics system. So yeah, so we have, again, we're testing multiple transforms, or we can even test the whole bronze, silver, gold pipeline if we need to. And then we have end-to-end tests, where we are testing complete system in a production-like environment. We might be testing with sample data. We might be testing with real data. We're testing the entire pipeline, basically. And these are sort of the most pain in the neck kind of tests to set up, because there's so many components involved, but they're very, very important. And because of their scale, obviously they're the slowest to run. And usually you test these before major releases, before any sort of releases to production, I'd say. Cool. There's another kind of test that is sort of unique to data engineering, and that is data quality. And we have a little diagram there. This is ChatGPT interpreting what a happy data engineer looks like with some data quality tests. So right, what are data quality tests for? They validate the correctness and consistency of the data that we get into our pipeline. So we're talking schema tests, we're talking nulls, we're talking ranges, uniqueness, referential integrities. And obviously the speed can vary depending on what you're testing. And when should you test that? I think personally you should test it at every step of the pipeline, but especially on ingestion, because you can get a lot of garbage data coming in. And I've had this in practice working on projects. So you need to clean that up. You need to separate the bad from the good and promote only the good, and sort of consult with your upstream sources on how to fix the bad. Right, so that's essentially the sort of types of tests. Anybody have any questions so far? All pretty familiar stuff, right? Cool. So this workshop, again, is going to focus primarily on unit tests and integration tests and some data quality tests that we can actually run in a containerized environment. So maybe I will quickly just show you what Databricks looks like for those of you who haven't used it before. So this is sort of the Databricks UI, and Databricks has things called notebooks, where basically you define your code and your transformations. You can have blocks that are basically metadata. You can have Markdown. You can mix SQL and Python code, and you can run these in sequence, basically. And if you're using a specific kind of notebook format, you can also just experiment and run this in all sorts of different ways, in different orders, depending on if you actually have all your dependencies imported correctly. Yes. Yeah. Absolutely, yeah. There we go. So yeah, it's just code mixed with basically some descriptions, some fancy descriptions, or some code in other languages as well. But we're focusing again strictly on Python. So now going back to our presentation, basically how do we make code testable? So one of the things that happens when you're working in these notebook environments is that you just get this guy up again. There we go, slideshow. You can really fall victim into this sort of exploratory, experimental mindset in the notebook, where you just write your code procedurally, you just write it out in sequence, you write it in sequence. As you can see here, we're reading a table, we're filtering there, we're then adding some columns, and then we're writing things. You can have this split across multiple cells, but it's not very testable, you know? It's not, you can't test individual logic. You're also tightly coupled to the Spark session. So a Spark session is basically your context, your sort of interface to Spark, right? And Databricks sort of has its own Spark session natively that it provides you. If we would like to test our code outside, we should be able to use our own sort of Spark session. Right, so it's hard to mock dependencies. So yeah, it's not very nice. You have a monolithic notebook, basically. You can have multiple of these doing all sorts of transforms, reading tables, filtering, and whatnot. What we need to do is we need to modularize these. Every sort of transformation that we do, we move it into a separate function. We move it into a separate function where each function can have its own single responsibility. And then it's basically pure transformations or pure sort of reading input and outputs. And they're very easy to test in isolation. And again, this is pretty common knowledge, right? Put your tests into sort of atomic functions so you can test them better. And obviously you can reuse them across notebooks. Another example here is where we have a process customers function. It can be anything. But what's interesting here is that we can also, what we should also do in the context of Databricks is we should inject our dependencies. So right now we are injecting our Spark session, which gives us the flexibility of being able to test this function in a different environment where we can supply our own Spark context. And things like source tables and target tables are also very easy to configure in a testing environment because we can write to whatever we want. Now, the convenient thing, why are we talking about this, right? Databricks works with delta tables. Are you guys familiar with delta tables? So essentially, delta tables are Parquet files. They're files that with some metadata. That's your database, right? So the convenience that that gives us is that delta is, first of all, an open source format, and we can just use that anywhere. Right? It's not the same as being on GCP and being tied to something like BigQuery, where that is a proprietary database system. You can't really have that offline. Then you are, inclined to do all your testing against that cloud database. Right. So, we're making our code testable. Modularity brings flexibility, and it allows us to do, most importantly, dependency injection within the context of Databricks. That is very important because we would like to be flexible with our own Spark session. Right, so what are we doing? We're talking, how do we approach this? How do we test locally? We containerize things. So I presume a lot of you are familiar with Docker containers. Yep. So, and we can do that. We can do that because, again, the technologies that Databricks uses, for example, PySpark and Delta, these are things that we can actually containerize. And that's great. So all we need is a container with PySpark, with Delta Lake support, and that's it. We can pretty much run this on any machine that we want. It's directly CI/CD compatible. And there actually is already an official Docker image by Delta themselves, which supply you with Delta Lake and PySpark. You will have to ensure that it actually matches the version of PySpark that your Databricks cluster is using, but they have their own release tags, and they should line up. Yep.
Should it be the same environment?
Should be the same environment.
When you test,
yep.
You want to execute the test, you want to have the same environment of the production.
Yeah, well, in terms of, are you talking about in terms of Databricks and sort of the version of?
Have the same environment of it.
Yeah. Yeah, exactly. So in terms of the environment, right now we're talking about basically the PySpark and the Delta versions that they have.
Because you might succeed in custom environment, but you might completely fail on the.
Absolutely good point. And so basically, to take a step back, essentially these tests, they're not meant to replace running tests in your Databricks environment. They are meant to supplement it. These tests, you can run them before you even deploy to the pipeline. So you don't run anything on Databricks. You don't sort of accumulate any cloud costs. You can run this in your CI, and basically, okay, well, we have our modular sort of individual functions. If something breaks there, we will be able to catch it early on before actually deploying it into a test pipeline or a staging pipeline. That's the benefit that this brings. And so you would want to match these versions together. They're probably backwards compatible, but I wouldn't suggest it. Just, match it up with the version that you have on Databricks. Any other questions? Cool, moving on. Right, yeah, all the good stuff. So what we can test now with this containerization, what can we test with real dependencies? We can test PySpark data frame operations. We can test Delta table reads and writes, any business logic transformations as a result of this, and data validation rules as well. What we still need to mock, Databricks specific features such as autoloader. So autoloader is basically a way of streaming from cloud storage. So you're able to stream files, and you're able to checkpoint the streaming, and sort of it basically encapsulates a lot of the logic to ensure that you don't re-ingest data twice. External cloud service interaction. So for example, connecting to Event Hub. However, we're going to have a bit of we're going to bypass this a bit in today's example. Are people aware of what Event Hub is, by the way? It's sort of basically one of the streaming services available on Azure. And what they do have, what Event Hub has, is actually they have the ability to stream via a Kafka endpoint. And Kafka is basically a real-time streaming library. You people are probably familiar with that. And if we have something in Kafka, we can also bring Kafka to a container. So, right, and then streaming write operations. This is actually wrong. That is also possible. Right. So it's mostly kind of like input-output interfaces that are related to your actual cloud environment that you can't really, you're going to have to mock that. Right, and with that done, we can actually start looking at the workshop. So I don't know if you guys want to take a picture of this QR code, if you guys want to experiment with that in your own private time. I'll give you guys a couple of seconds to do that. And then I will sort of guide you through the code base and explain what it does. All good? Perfect. Cool. Before that, let's just talk about this example sort of pipeline that we've set up for this demonstration. It's not by any means, kind of a production pipeline. The purpose of this is to have something here to show you how you can test these individual components. So we have our landing zone, which is where our data comes in. We have some customer data coming in CSV files every day or so, and these CSV files will always reflect the latest state of your customers. And then we have customer orders coming through Event Hub. So it's a stream of orders coming through, basically. So what we do then is we obviously ingest this data into our bronze layer, into a Delta table. And then we begin our transformations and validations. We will go to our silver layer where we begin to validate and deduplicate our customers. And any invalid customers are going to be sent to an invalid table. Obviously, in data engineering, you never want to drop that data. You should always isolate it, because then you have basically an audit history, you have the records there, and what you should do is consult with your upstream data providers to fix those data points. Once that is done, we also do a similar thing for orders. We validate and deduplicate them, and then we send the invalid orders to the invalid table. After that, we will perform a simple join between the two data sets, after which we will then promote this data into a gold table, which is basically a daily revenue report. It is essentially your, how much revenue per day per country. And that's basically it. Let's talk about the inputs that we're going to have. We have our orders coming in. These are the data models. We have an order ID, a customer ID, a timestamp for order. I didn't change that name. I'm very not fond of acronyms. Amount and currency. And then for customers, we have our customer ID, first name, last name, email, sign up date, country, and valid from, which is sort of a timestamp that basically reflects the latest state of that customer, whether they did an update on their profile, and so forth. So now we have all this stuff. It's a really simple model. Again, nothing complex. How do we set this up on Databricks? So are you guys familiar with Terraform? Right? Good stuff. So Terraform allows you to quickly create your cloud resources using code rather than having to go through the UI or using their command line tooling and so forth. It is a universal tool that works with multiple cloud providers and many other sort of services. But basically, we have some Terraform code in this repository that you can essentially pick up. If you can go ahead and create a trial account on Azure and then just run this Terraform code to create your resources. And what it's going to create is basically your Databricks workspace. It's going to create your event hub, which is your streaming sort of service where we're going to stream the order data coming in. And it's going to create some storage accounts where they're going to serve as the drop-off for customer CSV data. And then aside from that, basically, Unity Catalog is used for governance and for managing permissions of access to data. And these are all coming through an access connector that allows Databricks to authenticate to read from Kafka or Event Hub and the storage accounts here. That's about it. Any questions? None? Cool. Awesome. Then, without further ado, let's dive into the code base. So in this code base, we have some example data. And apologies to all data engineers. This is a very small data set that I did purely for demonstration purposes. But basically, these are your customers that come in. These are your orders that will come in. In theory, it should be much larger for even a demonstration, but that's fine because, again, they serve their purpose for the testing. We have our infra folder, where this is where we have defined all our Terraform resources for creating what you saw earlier there. And then we have 3 folders, right? 2 of these are very crucial, and they're crucial parts of Databricks. So typically in Databricks, you have your notebooks, right? And as I mentioned before, people like to just write all their logic and dump all their logic in notebooks. And I've seen this in practice. And I've seen notebooks running in production that are not modularized, are not tested, and that's a big bad. So what Databricks does correctly tell you to do is you should modularize these functions. And that's why we have a libs folder here, where we have all our function definitions. So we have a function for computing our daily revenue from the customers, which takes in the data frame. We have some helpers here for basically adding a processing time between each layer. Just some schemas for the Event Hub orders. And then basically deduplication functions, parsing row orders, and performing the merger between the customers and orders tables. And then some validations where we validate each sort of model. Now, ideally, you would probably split out. These are just like generic big validation functions that hold many validations in place. You should probably split that out even into smaller pieces. But again, for the purposes of this demonstration, that is fine. And these functions, some of these are used throughout the notebooks. So yeah, we have modularized most of our important transformations. We've moved away from from keeping this in notebooks. What this then allows us to do is write unit tests for all of them. So we have our unit tests here for every single function that we have in place. Similarly, again. Now, the interesting part is the notebooks. And these notebooks are Python files. And I will tell you something about notebooks in Databricks. You can have notebooks in 2 different formats. Oh, what happened there? You can have notebooks in a format that is known as the Jupyter format, the IPyNB format, which Databricks seems to recommend. But you can also have them in Python files. Now, the Jupyter notebook comes with its own benefits in the sense that it's very nice to use as an interactive environment to play as a playground. But when it comes to things like source control, that doesn't look very good. And additionally, I mean, you know, it has its own file format. It's very hard to keep track of what changes have happened. There was a nodding there that I saw earlier. But we are using specifically the Python version of this. And what the Python version looks like, so you see all these code blocks. Delete that extra code block. What that looks like in Python is just this. All the code blocks that aren't really Python code are just comments. And that's cool, because we have a Python file now.
So you can edit the notebook and then it will represent the Python.
Yeah. That's how it's saved, essentially. Yeah. So basically, that's and that is a cool thing. Why is it a cool thing? Because what we can do is we can actually wrap our notebook into its, and we can have a single function that dictates what this notebook is supposed to do. Now, this function can be calling other functions within the notebook, but basically I define something called a main processing function. And this encapsulates all the logic that this sort of notebook must do, all its transformations. So in this case, for example, in the customers, and I think this is the silver layer, we are validating and deduplicating new customer data. And we're doing this in our main validate customers in silver function, where again, we use dependency injection for providing our Spark session. We provide our target and source tables. And then that's it. We perform all of this. This shouldn't be here. What's great is that basically we can then have our handy Python clause here that checks whether you're running this file directly. And if you're running this file directly, here you can have all your sort of Databricks environment specific setup, and you can pass that into your generic function and just run the notebook to do what it's intended to do. However, and with this separation, we can actually, because this is a Python file, we can actually import this function into our tests. And what that allows us to do is to perform integration tests. So we can have integration tests per notebook. We can have integration tests across notebooks. Any questions? Cool. Right, so that is the notebooks folder here. And then finally, in our tests, again, we have one fixture for a Spark session. We are using our own Spark session here. We build it. This is not provided by Databricks. And we can pass that into our functions, which now accept this as a dependency. And as I mentioned, given the fact that we've structured our notebooks in such a way, right? Because again, there's many people love using notebooks in production. I'm saying, cool, use notebooks in production. But if you're going to do it that way, put them in a format that allows you to make them testable. I'm happy for you to have notebooks in your staging environment where you can experiment and use that different format if you have to. But for something running in your pipeline, use a structure similar to this that you can then import and test. And we have, again, our integration tests written here. So, and one thing that we are actually doing here as well is we're using Kafka running in a container to also simulate the orders coming in. So that all works. Now, how is this all done? Again, we are using containers, and we are using a Docker file specifically, which is present here. And that is coming from Delta.io. We're basically pointing it to use a few packages, specifically Delta and Kafka. And other than that, we're just installing our requirements. So our dependencies, which are present, where are they actually? somewhere there should be requirements. There we go, yeah. Just PyTest in this case. And that's it. And we use that in this Docker Compose file, which basically allows us to run multiple Docker containers. They can obviously communicate amongst each other as well. But there's two core sort of services that I've defined here. There's run tests and run tests local. There's a reason that I define, that I distinguish between the two. And it's because of my machine, specifically that it's a Mac. So this is the core thing, right? We're running tests, we're using this Docker file, and we're simply mapping the volumes of all our folders. So we have our tests, we have our notebooks, and our libraries. And then we're just telling it to run PyTest against our tests. Run tests local is pretty much taking the same stuff here and just setting an environment variable where we actually override the host for Mac to not use localhost to communicate with Docker, but rather use host.docker internal. It's just a specific kind of annoyance that they have. But that's fine. We can run this here, and we can run this in the CI. So, but before we get into that, let's just take a look at running our pipeline, right? So here's a little pipeline, our tasks. I don't know if you guys can see well. And I just, no, that doesn't do it. Great. Anyways, yeah, you know, we're ingesting customers, we're ingesting orders, we're validating them, and we're building the customer orders, and we're then building the daily revenue table. These are all a sequence of notebooks that we run.
So is there like a one big notebook with type all the notebooks?
No. So these are all the tiny notebooks, and you come into a job or a pipeline, and you basically define, in this case, yeah, you build a DAG, exactly. And these have their dependencies here, and we can just run this to ingest our data. So I have my customer CSV files in Azure in a storage container here. Which again is created using Terraform. So we go to our source, and there we go, customers. I had exchange rates, but I decided to make my life easier by making this problem statement simpler. So we just have customers here. And then we have our event hub, which handles this sort of real-time data streaming. Obviously, there's no messages coming in. I have a convenience notebook created here for loading our example dummy orders onto Event Hub. So if I come here, notebooks, test utils, write Event Hub data. We can effectively just write our data here. In fact, let me just create everything from scratch for you guys, because I've already created these catalogs. I'm just going to drop all the data. Never do this in production. And then bronze. Cool. So now we have no data. This is our catalog, which in Databricks allows you to see your essentially your tables. We have nothing here. We are using a schema called bronze, silver, and gold. And we're going to build these out now. The first thing we want to do is we want to write data to our Event Hub stream. And this convenience notebook does just that. It reads that orders JSON file, and it just loads it onto Kafka. And by the way, for those of you who are familiar with Databricks, we're just using a serverless environment right now. We're not actually using any compute, so we're not setting up any clusters. Because these are batch jobs. We're using them as batch. Obviously, if you want to have continuous data coming in, you'd have to keep your cluster running. But for the purposes of this demonstration, we keep things simple. So yeah, that's all the data that has been now loaded on Event Hub. We should see it coming through as a request. There we go. We got some successful messages that will come in. Well, they should pop up here. Anytime, my friend. Okay, well, it's delaying to show the graph, but we can just run our pipeline and just have it take that data in. So let's just do that. And this is the part where everything fails due to demo hell. No, fingers crossed. All right, so now we're running our pipeline. Are we or are we not? Run now. Thank you very much. Okay, I'm running it twice. That's fine. Yeah, we don't need this run. All right, let's go back to jobs and pipelines. So we're seeing this running. And now what it's doing is, again, it is basically ingesting, then validating, then building the customer orders table, and then finally the daily revenue. So going through all these steps. And what it is doing is it's running notebooks. So you can come here and you can see the actual notebook that it's running. And any sort of outputs as well.
For example, in DBT, you could set this, you typically would set this tag also in code itself. Can you do that with Databricks, or do you have to like manually do the tag?
You mean the DAG? You can do that with Databricks, yeah. But you basically what you can do is, I mean, Databricks, you can connect a CI to it, and just have it set up your things, and I mean, you can yeah, basically Terraform it as well if you want. I did not go down that route because I had to tear my hair out to set up the Terraform resources for this. So, but yeah. And yeah, we can see all of that is now running. Everything's green. Yay. I'm not on demo hell today. And what that is doing, as you will see coming into our catalog, we now have our bronze layer, which has our ingested data. We can sample the data here. We should be sampling the data. You should be showing me the data. Why are you not? So let's do this here then. No. Why? Let us debug this. Why have you done me this way, my friend? Oh, I know why. Yep. Sorry. I know why. That makes a lot of sense. Any of you guys familiar with structured streaming in Spark? So basically, structured streaming in Spark allows you, the way you ingest data as you stream, you create something called a checkpoint file. And that checkpoint file allows you to track what data you've previously ingested. Now, when I deleted those tables and I cleared everything, I didn't clear my checkpoint files. And that thinks that, okay, I've already read until this point, so I'm not gonna take any data in. So let's quickly fix that by going into our storage accounts again, and our containers, our checkpoints, and we're gonna go to our checkpoints here. I'm gonna delete these guys. All right, just gonna force it to redo everything. So apologies, but here we go for another pipeline run. And now let's just check immediately. When these complete, we should be able to see some data coming in. God, it's very hot in this room, isn't it? I wore this hoodie. I think it was a very bad decision. Come on, bruv. There we go. Is it the right one that finished? Ingest customers. All right, please, let's see some data. There we go. Great. There was some malformed bad data here that we can validate on down the pipeline. But yeah, that's come in. We get our orders coming in as well, I imagine. Good stuff, right. And then we have our other guys. Cool. Validation layer. And all of that. And then we're finally going to build our daily revenue table of 3 records. Again, apologies for using such a limited data set, but that's not the main purpose of this workshop. And in the meanwhile, while we're waiting for this, I'm just going to show you, let's just run the tests locally of everything that we're doing here. We have our Docker Compose file. Again, we have our unit tests in here. We have integration tests, testing the whole logic here. All we need to do is do Docker Compose up, run local tests, run test local. That's it. Collects 103 tests. And it's going to take a little while to run them all because of the integration tests. They're slower than the unit tests. And hopefully we should see the same result here. As you can see, this is PyTest just running. These are successful test passes. If there's an F, we're in trouble. In the meanwhile, our beautiful, very useful pipeline has been built. We can see in our gold layer, we should have our daily revenue of amazing $200 from, where is it? Germany, Vietnam, and US. Such a successful business, right? Cool. There we go. Our tests running in our container here, testing every piece of logic in the pipeline. What we can do is also run these tests in our CI. So Databricks testing workshop, which, there we go. This is the private version of this repository that I've shared without the horrible commit history. But what you can see is, let's just rerun some checks. We have our CI, which is set up here in GitHub workflows. For those of you unfamiliar with GitHub workflows, it allows you to set up basically your worker here to run any sort of tests or deployments that you want. In our case, our CI is pretty simple. It is always going to run whenever we open a pull request to develop or main. And then it simply downloads Docker and runs the same commands. Now, why is this useful? Because we get to run tests before we touch the pipeline. What you should do afterwards, after this step, is then deploy to your pipeline and then run things there. But this will allow you to catch things early on. This will allow you to catch whatever developer is working on whatever PR. If they change some logic there, that's going to break the test in your sort of unit tests, and that's not going to progress into running things on the pipeline. Yes?
Back to my question. So you are using an environment which is different of the production environment.
Exactly, yeah. Well, the similarity here is the engine that we're using, PySpark and Delta. So they have the same API. We're using everything basically based on that logic. But yes, this doesn't discount or replace tests that you should run in your production environment.
Asking you test on your customer environment, why it's going to break on production.
Yeah. And in that case, what you do is you add another step here, where you then deploy your wheels to Databricks and then run tests there. And when that passes, then you can merge, essentially. I haven't done that because that is common practice. People are doing it to test things online already. And it's also a headache to set up with Terraform and things right now. So I haven't gone ahead. Yeah.
the test pyramid, right? Why you need to have tests at each tier with this
Yeah.
test.
Yeah. And what's actually nice about this image from Delta is actually it comes with a Jupyter environment. So if you want, you can play around locally with a notebook-like environment and set up your transforms that way. Though, you know, I think it's nice to work on Databricks. Right. So let's see. Nothing failed. Great. And similarly in the CI, did I run this? I didn't rerun this. Anyways, you get the point. It's just we run the job. It's going to build it out again. We can go to actions. We can go to our history. We can see our example implementation the last time we ran this. Took a while to download our resources, but there we go. We have all our tests clear. And I think that kind of brings us to the end of our workshop. I wanted to complain a bit towards the end of that. I set up a test trial Databricks account, and just for running these simple pipelines on a serverless account, I accumulated £63, 63 pounds of cost, and I absolutely hated that. But thankfully, they gave me $200 free, so it's okay. But yeah. So that's why we can execute tests now in our environment. Yeah. Cool. So that is basically it. Thank you very much. We have a QR code there that you guys can scan to give any feedback to these sessions. You know, if you hate my outlook on no notebooks in production, we can fight for it later. It's fine. But basically, yeah, just let us know your thoughts on how we can make this better. And yeah, hopefully you guys found this useful and informative. And thank you all for coming. Right, I think we can stop sharing. Any questions? Yeah, Q&A. Yes. Performance tests would probably be you're talking about like with large data, right? Exactly. Yeah, you would probably do that on your pipeline environment. So this in a local environment, how much data can you really sort of? But very crucial. And you're right. It could have been another section in the tests that we had. Yep.
But your other thing was that you kept apologizing about data being small.
Mm-hmm.
I think it's serving its purpose. I don't think it's small. It's enough as long as you have a different quality of data. I mean, different type of data set where your logic hits different way.
Yeah.
Then I think minimum is good enough if you could run.
Yeah, it was. I wanted to definitely save some time. So yeah, but yeah, no, thank you. Yeah, and you're absolutely right. Performance tests are very, very important, and data quality tests, where, for example, you saw there our data pipeline here, where we had. Let's go back to that fancy schmancy diagram, which I've lost now. Where was that? For example, you have your invalid tables here, right? Orders invalid. You set up monitoring on these things. Whenever things come in, you basically, so you're able to act on them accordingly, right? Yes.
So I was thinking, once you have built this beautiful unit testing, the test set, you manage to like refactor all the transformation using AI.
With AI.
Yes. So once you feel like it's beautiful, because you have like some logic built by the customer, they know this stuff. Then you bind the code and you build the test. Once you have this beautiful test suite, you can just ask AI, cloud code, whatever, just refactor and put them in very nice modules and you pass the test and you're just almost sure that they're actually doing like a.
I think anytime you use AI, you should probably look at what it gives you. I'll be frank. I had AI help me write all this stuff because it's a lot of tests. But I went through every single point and to make sure that. Or does that not answer your question? Yeah. I don't trust AI either.
Take the same. Can we build like a test suite?
Yeah.
Right? Version test, new test. Once you have that test that you can really rely on any output that, or at least verify and validate any output you're getting from.
Oh, right. To validate your data quality or something, whether it may the transformations with AI. I guess you could. I guess you could have basically your AI sort of validating your code.
The test.
Mhm.
So your detection test.
Yep. Oh, and then AI to tell you if you've missed anything. Okay.
So actually, the value is more in the test suite than the factory.
I'm sorry. I am. Oh yeah. If AI makes changes and you've got tests covering it, and then if AI does something silly, your tests, in theory, should catch it. But then again, your testing is only good as good as the edge cases that you cover, right? So it's always a sort of back and forth. But yeah. Any other questions? Yes.
That was a very good example of refactoring for testability. I
Thank you.
wonder, in terms of code coverage,
Mhm.
so you can use standard code coverage tools under our Python.
Mhm.
We would probably not be able to cover much of Databricks, right? So if you want to see coverage of this whole data aggregation pipeline.
Well, in theory, yeah. If we're using basically a tool to scan these Python files, probably not. Though I mean, it depends, right? If your Databricks is using different languages, and that's a different problem. I'm sure you can sort of approach it in a similar manner. But I don't know how sort of testing coverage happens on Databricks. I would approach it by at least trying to do this first and checking the test coverage of my Python code, because I save everything as Python, basically. If it comes to notebooks, I don't know. Yes. Mm-hmm. Yep.
Which the one you of course you showed the
Mhm.
if you have that worked out, right, how would you what would the best way to do that?
To do an end-to-end test with this containerized method?
I mean, without having, say, access to this code. If it's deployed in this environment.
I mean, you'd have your inputs that you give in your expected outputs, right?
Yeah.
And then you just look at those. So if you do that in Databricks, you could create basically. So in Databricks, you obviously select the catalog and the schemas and whatnot that you read data into. You can obviously set your source locations. So what you could do is you could have your test pipeline look at another container. Where you have your sort of selected data sample that you want to test. And then you have your expected sort of outcome that you want. And what you can do is, again, in the CI, you can deploy this to Databricks, have it target that sample data, have it run the pipeline, and then you can inspect the results, again, using Python or whatever logic you want, and compare the two.
Yeah, sure. Also, we could, if you want to go a little bit deeper into it, like just transform, we want to do black box or these transform as well. Because it's Databricks, I'm sure that you can just query similar to what you showed.
Yeah, you can query the tables, right?
There's this
Yep.
monitoring different stages of
Absolutely. So as long as you have sort of you've got your isolated environment where you know exactly what's coming in, you can then just query each table in the pipeline and see, like, is it what we expect?
Yeah.
Are the results what we expect? Are they the bad records correctly being flagged? It's just running SQL queries and doing comparisons.
So in terms of data quality tests, I know like in DBT you have DBT tests or you could plug into like Monte Carlo, which has like some anomaly detection. So does Databricks have anything like that?
So it has basically, let me find it. Where was it? I was looking at it the other day. Oh, there we go. Insights. You can set up insights, and or is it maybe the wrong place? I actually have never set it up on Databricks, but you can basically, first of all, have a dashboard where you define your thresholds for data quality, and then that's, you know, if anything crosses that threshold, you can raise an alert using a webhook to go to wherever or send emails and so forth. And obviously, in our case, if we're having a pipeline where we have these invalid tables, you would really want to focus your monitoring on there. Yeah. Anything else? Probably. I haven't used any personally. There's definitely tools that will generate for that. If you specify your model schema, you could even write a simple Python like script to give it a schema. It'll just random dump. Though it probably won't be as intelligent data. I'm sure there's more intelligent solutions that actually give you more realistic kind of data.
Have you tried to explore more of the limitations?
No, I haven't. Of this or the you mean the data generation stuff?
Yeah.
Testing my code. I mean, I'm sure that it's not foolproof, this thing. It's just here to demonstrate what it is. So maybe there's some edge cases I missed and things like that. Just break the shit out of it. But basically, the idea is you test your
Yeah. Not you wouldn't was talking about your logic or your code.
Yeah.
Talking about what you cannot do, cannot do on this particular framework.
So Databricks, you mean?
Yeah. So what's the limitation on how much you can test and how much you can't test?
Well, I mean, you can basically test. You can essentially test your full pipeline. So as far as that's concerned, you basically you have things like in your notebook, you can set variables. You can basically have variables here. There's sort of like a box. I forget the syntax for it. You do base dbt utils, db utils something, and you can set variables which allows you to basically, they're parameters you pass to your notebook, and that can allow you to target different tables. So by that logic, you can set up a test pipeline that purely targets test data. And then it builds sort of catalogs that are prefixed with a test underscore or your GitHub runner number underscore, things like that. Yeah. What is it called again? Sorry.
Evo SQL.
Evo SQL. Yeah. Nice. Save that. Very nice. Yeah, I'm wondering if we can maybe use this with because Spark has a SQL interface, but I don't know. I'd have to look into it. But I'm sure there's some libraries that exist. Just have to find them.
This might be a silly question coming from someone who's from more classical engineering background, but is there like a concept of mocking that you mock out dependencies?
Yeah, I mean, in my case, I've mocked out, for example, something called autoloader in the integration test, which is a Databricks specific. So Spark streaming is Spark, but Spark streaming can have different formats, and Databricks has a format called cloud files, which I can't bring in this container. So it's just simply for reading files. So I mocked it out and I just gave it some data. I could have mocked out the Kafka stuff. I just chose to be a masochist. But yeah, I don't like mocking. If there's a moment where I cannot mock something and I prefer to do that. But obviously, that can lead you down a rabbit hole that.
So yeah, like typically when you're going down, the lower you are on the test pyramid, right? So it's this unit test that you will mock a lot more. I'm not sure if there's a concept of mocking libraries as well. Yeah, so
I guess you could.
It's kind of auto-generate.
I guess it's it's under the hood, it's PyTest, right?
Yeah.
So
Yeah.
whatever PyTest allows you to.
You can mock any, I mean, it has a, as much as I hate the mocking interface of PyTest, because there's so many ways you can mock stuff, you can do that. Yeah. Anyone else? Awesome. Well, thank you guys. Thank you very much. All right. So.